Hi, this is Rick for EDU Mobile. Now we're going to look at a protocol. A protocol defines some behavior for some instances or for some instance types that we might want to apply to more than one instance type. It declares properties and methods that we want to define in some other type to inherit some behavior, but not really to define what that behavior might be. So I have a protocol here named Scalable that declares a single method, scale by. Now in Swift, protocols defined as Swift protocols have methods and properties that are required. There is a way to get around this behavior, but it's kind of strange, and when we need to do it, I will certainly show you how to do it. But just think of it this way. A Swift protocol is everything declared in it is required for use by any class or structure or any enumeration that adopts it. So here we have a protocol. It defines one function, required function, scale by. Scaling is just changing the size of. Really, this multiplies, but we'll talk about the implementation when we adopt the protocol. So scale by takes a double value as a parameter and returns any. You could return a particular type, but you'll see in what I'm doing that I want to return multiple types from this protocol method depending on what I'm scaling. So in the first case, I've got a scalar. What's a scalar? It's something that has a enumerable value. So here I have a scalar, and I say that it's scalable. What am I doing? I'm adopting the scalable protocol. By the way, if you subclass and adopt protocols, you separate them by commas after the colon, but you put the superclass first, and then any protocols that you're adopting. Okay, so back to the real topic here. Scalar has a value, which is a double. And then we initialize it because we didn't initialize it in the property declaration. And then here we define the function that I'm adopting from the protocol. So here, since it's a scalar, we're going to define the scale by function as just multiplying self.value by a value. And in this case, because self.value multiplied is a double, and we're multiplying by a double, we're going to really be returning a double. But we're returning any because that's what the protocol says. Likewise, I have a structure here called matrix 1D, a one-dimensional matrix. I'm just keeping it simple here. It also adopts the scalable protocol, but I'm storing my matrix as an array of doubles. And here's where this any parameter comes in very handy, or this any type. So I initialize it, self.matrix equal matrix, as an array of doubles. I'm also going to define a subscript, but we'll talk about that here in a moment. Here I have scale by, which is a value, which is a double as a parameter, returning any. But now notice what this returns. I set up a product as an array of doubles, and this is an empty array. This is my empty array syntax. And then I count through my matrix and append the current value of that count times the value I'm getting in as its property into my product matrix, and then I return product. Up here with the scalar, I returned a double. Down here, I'm returning an array of doubles. This is the power of the any object, because a double and an array of doubles are two entirely different types. Now, it's also nice to be able maybe to subscript into a matrix 1D. Now, we could certainly do this by saying my matrix dot matrix and then a subscript, because this is an array. But let's define a subscript just on the instance of my matrix itself. My subscript is defined as my index to the subscript is going to be an integer and return a double. And it's read-only, so we don't need the getter. We don't need the get declaration if it's read-only. We only need a get and set if we use both get and set. This is true for subscripts. It's also true for computed properties as well. we return matrix at that index. This is a very simple subscript, but it's very powerful, as we'll see. So we've let my scalar equal a scalar with a value of 4, and we've let my matrix equal a matrix 1D, where we set matrix to the double matrix 1, 2, 3, and 4. Now we scale my scalar by 3, which gives us 12. 12 times 3 is 4. And we scale my matrix by 2, which gives us 2, 4, 6, and 8. By the way, we could scale my matrix by anything we wanted to. If we scaled it by 4, we would get, there we go, 4, 8, 12, 16. Now, here is my subscript in action. Notice, though, that the return types, scale by 3 is giving me back a double, scale by 4 is giving me back an array of doubles. So this is that any operator, the any type, which is very cool. And then my matrix sub 3 is, of course, 4 here. Okay, now, actually, let's see. My matrix sub 3 is actually, I don't think the playground has updated here. Let's force it to, my matrix sub 2 is actually, there we go. My matrix sub 2, 0, 1, 2, is 3. Because the scaling operation doesn't actually change the underlying value of the matrix. We're just returning a matrix that is scaled by this. So, yeah, the playground just hadn't updated its values. So there you go. A couple of things here. A protocol, and we could certainly have a property here. We could have more than one method, but remember, with Swift protocols, the methods and properties of the protocol are required. So keep that in mind. And also, we've also used a subscript, which is a nice way if we want to subscript into something without having to use a dot operator to get to the underlying subscriptable property, or where we don't have a subscriptable property in the first place, and we just want to define some kind of maybe a computed thing that we're going to return as a result of subscripting into a class or a structure or even an enumeration. Thank you very much.